Hi everyone, this is Tushani Hera, the Achem Lab Director. Welcome to 376K for spring semester. And I'm recording this so you can listen to it and learn all about how we run this class this semester. So before we start, just want to give you a little overview of what we are trying to do here. This is a very unique experience you get at UT Austin. This is the most advanced analytical chemistry lab that you will take, and we designed this to be more of like a sandbox for internships because we're trying to cover a lot of learning objectives through this course, not only just the academic knowledge or the instrument skills, but also some soft skills that you will need when you get out there looking for jobs. So what we're going to do today, I'm going to go over the class structure because there's so many moving parts to this semester. So I want to kind of be very clear of how we do things. And then we are going to talk about a little bit of round robin labs because round robins are done slightly different way than how it was in 456. So I want you all to know how we're going to do that and prepare for it. Then we'll talk about special projects and I'll give you a quick overview of instruments we have. And there's a Q&A session usually if I've done this in person, but feel free to add your questions as comments when I share this video. That way I can answer them. And your TA will be sharing a separate video to tell you about who they are and how to contact them and all those important stuff. Lab safety, you've probably seen this before in 456, and it's a very unfortunate situation, but I want to emphasize how important the lab safety and how unfortunate it could be if we don't pay attention to certain things. It's crucial for this semester because you're doing your round robin experiments. We know what to expect and what can go wrong. But when you're doing special project in 376, that's a very, very unique situation. Each one of you will be working on your own chemicals, and some chemicals we haven't seen before. We haven't used it in our space before. It could be really new journey for all of us. So I need all of you to be very responsible and pay attention and learn what to be careful about, what safety precautions that we should take when you're dealing with different chemicals and preparing for your special projects. So speaking of how to get yourself ready with lab safety, we do have this refresher module on Canvas. It's the same module like last semester, but it will give you a little quick refresher. Take that module, complete it, take the safety quiz and complete the Google form link, which is very important before next week because in next week we will do round robin experiments in lab. This is the weekly schedule and this is the weekly schedule and you can see who your TAs are. My office hours, Tuesday and Thursday in these times, and I do it through Zoom. But you know where my office is, so you're welcome to stop by whenever you have questions. I have an open door policy. If I'm there, just walk in and then we can talk about what you need. Okay? TA office hours will be shared through their video that they will create. Okay, about the lab. As you know, this class is a lecture plus lab. And when it comes to lab component of the class, we have two major areas to focus on. One, regular round robin experiments. This time, you're doing round robin experiments on spectroscopic techniques. You've learned separation electrochemistry before in 456, but in 376, we are covering all the spectroscopic techniques as round robin experiments. And then we have a very important part to this class, which is the independent project or your special project, which will happen during last 6 weeks of the class. However, to do an experiment, an individual experiment during the last 6 weeks of the class, we need to get yourself prepared step by step from the beginning of the class. So you'll be taking some assignments related to special projects while you are performing the round robin experiment at the first part of the semester. All the round robin reports are done in groups, so you'll have your own group to work with, and the reports will be all group reports. You'll be working with your group members to create the report. So it's a one report for all of you in the group. And you will get some extra credit for working as a group and sticking to the group agreement and so on. As you know, there are different types of reports that we use. In 456, we've done quite a lot of different versions. But for 376, the plan is to stick to two kind of reports. One is JAG style. So as a group, you can pick one of those 4 experiments and then use that experiment to write a JAG style report. When it comes to JAG style report, if you remember, we did the GCF5D in 456 as a JAG style report, which has all the sections: abstract, introduction, experimental data and observations, and little bit of discussion and all conclusion and all of that. So it will be the same. You'll pick one experiment and do it in JAG style report. And the rest of the 3 experiments, they are more condensed scientific reports. You don't have to write an introduction, just write an abstract, experimental, data analysis, and there will be some discussion questions that you need to answer with the conclusion. So it's a more condensed version for the rest of the 3. How we do the grading breakdown. So each report, this time it's going to be 50 points. So you have 4 reports, that's 200 points. And then we have this special project. All the assignments related to this special project will be 250 points total. And the lab total will be 450 points, which I will transfer towards your lecture grade. And out of the whole class, it's the 30% of your final grade. And I'll add the extra credit on top of that. There are 3 most important rules to be successfully complete the lab requirement of the class. It's very important to have this hands-on skill when it comes to analytical chemistry. Instruments play a big factor of your understanding. Because of that, we want everyone to complete every single lab as a requirement. Also, we would like you to submit a complete report for every single lab, because each technique comes with a new learning objective or new skill to develop. Because of that, each report is important. So we expect you to complete all the reports to pass the entire class. And then total lab score, that has to be 50% of the total to receive a passing grade for CH 376K. I know life happens, so we need some ways to catch up, and I still have this time back option available to you. You probably know what this is. You will have 2-day grace period on one assignment or 1 day at a time for 2 different assignments. It's yours to take. You don't have to tell us why. You don't need to give any reasons. It's just there for you to use whenever needed. And you will have a separate time bank for your group work. Okay, so this is the lab calendar. You've seen this type of calendars from 456, so you're familiar. But for 376, it's crucially important because the due dates are not quite straightforward as 456. For example, next week, you will be doing your round robin 1. But the report is not due until the week of February 10th. So you will at least get 2 or more weeks to complete your round robin reports. Why? Because there will be other assignments related to special projects coming your way in between weeks. So I had this spread out so we don't have to have 2 assignments due on the same exact week. So please pay attention to this green text on this calendar, which tell you what are the due dates for which assignments and keep track of that, which is very, very important. There's no easy way for me to set up the due dates on Canvas so that it automatically pops up, because we have different people doing different experiments because of the group work nature of round robins. So unfortunately, that's not possible. So this is another way to keep track of which is due when. What you need, lab manual is your friend. That's what you need. Everything you need is in there. It's a big book, but every detail should be in there. I try to keep the canvas organized as much as possible. That should help you track where the things are. You can keep an electronic lab notebook, but if you still like those hard lab notebooks that you can buy, that's okay too. Additional reading resources are available on Canvas under Round Robin Prep module, which will be there for you to prepare for your round robin experiment. The optional textbooks are these: Quantitative Chemical Analysis by Harris and Skoog for instrumental analysis, which are both useful text, but it's optional. You don't have to buy them. Okay, about round robin experiments. We are going to cover 4 spectroscopic techniques: FTIR, FAS, UV-Vis, and fluorometry. Our stockroom manager, Angie Steelman, is working with us how to get everything ready for your experiments, and she will play a big role in 376, getting everything ready and tell you how to prepare for round robin experiments. And you will be listening to her for the rest of the talk to see what you need to get done for the preparation of round robins.
Hi, so my name's Angie and I run the stockroom, and I'm going to talk to you about the round robin experiments you're going to be doing for 376 this semester. So the first experiment we'll talk about is flame atomic absorption spectroscopy, or FAAS. The actual experiment you're going to do is analysis of trace minerals in carbonated beverages. So you're going to quantify sodium and calcium in Coke and Pepsi. The time it takes to actually perform that analysis is relatively short, so we're going to take advantage of that, and we're going to have you compare 2 different quantitative techniques. So you'll make a standard additions curve, and you'll also do a calibration curve. Ordinarily, you wouldn't do that. You would select whichever technique you want to use based on what your experiment is. But like I said, because we have time, we're going to actually do both of them, and you can see kind of how they work. The other thing you have to do for this is you have to acid wash your glassware. So what you'll need to do is come in to lab sometime before your lab, at least half an hour before your lab. And you will have submitted your glassware form before then, and I'll have a kit of glassware ready for you. And you'll come to the lab and we'll go through the process of acid washing your glassware. You'll let it soak in the tub and then come back typically at the beginning of your lab period, and you'll pull that stuff out of the acid bath and run it through a series of rinses. And we'll go over the specifics of all of that with whoever comes in to do it. But you will be responsible for acid washing your own glassware this semester. So another experiment we do is fluorimetry. The specific experiment is analysis of quinine in tonic water and urine. And the thing about this you need to know is you have to provide both a blank urine sample and you have to drink tonic water. And you need to do that at least 3 hours before lab, but not more than 24 hours. So it takes 3 hours before you actually start seeing quinine in the urine. And after 24 hours, it gets really hard to see. So that's our window where we want you to drink the tonic water and provide the second sample. So the Tuesday morning people are probably going to want to come in on Monday afternoon. Any of the afternoon labs can usually come in sometime during the morning before like 11 and do that. And then what you'll do is you'll come to the stockroom and we'll give you a specimen cup and you'll go pee in a cup. We'll have you store it in our lab fridge so you don't have to carry it around. And then we'll give you a tonic water sample to drink. And that's what has to happen 3 hours before lab. When you come to lab, there'll be another specimen cup in your kit, and you can just go and drink your, or not drink your tonic water. You've done that by now, but you can go pee in the cup again and come back and do the analysis. You do need to keep in mind that whoever provides the urine sample has to do the wet lab. So only you can handle your own urine. Another experiment you're going to do is an FTIR. You're using an FTIR instrument with an ATR attachment. The actual experiment you do is analysis of ibuprofen in an analgesic tablet. And what's really cool about this experiment is you're using solid samples. So many times the stuff that you use is in a liquid form, but you're actually going to grind together combinations of solids and you're going to run them as a solid sample. And the last instrumentation experiment that you'll be doing is UV-Vis. Our experiment is a multi-component analysis of a universal indicator. So what we have is we have one solution that we call a universal indicator, and it works over a large range of pHs. That universal indicator is comprised of 4 individual indicators. So there's like phenolphthalein and thymol blue and bromothymol blue and methyl red, I think is the 4th one. And you'll test those at different pHs because some will be one color in one pH and a different color in another pH. And ultimately what you'll end up is having a system of equations with a number of unknowns, and you'll use solver to go through and work through that process. So what's the big deal? The procedures for these experiments are written a little differently for the most part than what you're used to. And it'll be a lot less specific. It'll say more things like make a 10x dilution or make a 25x dilution, but it won't necessarily tell you how to make it or how much of it you need to make. So what you have to do is you have to go through your whole experiment and see all the times you use this particular solution and figure out how much of that solution you need. And then you need to figure out how much you're going to make of it, because if you need 17 mils, I don't have a 17 mil volumetric flask. You would end up needing to make at least 25 mils of it. So then you have to figure out how you're going to make it. If you're starting with a 50 ppm stock solution, how much of that stock solution do you need to make 25 mils of your 5 ppm solution that you need? So there's a lot more on the front end that you need to do for a lot of these experiments. And to do that, to keep track of all of that, you'll need to create your detailed step-by-step procedure for what's going on. That's the only way that you're going to get through this in a 3-hour period. You'll need to track who's going to do each step, and please include your solution prep calculations, because there have been lots of times that we've gone through and the data looks weird. And you think, okay, what's wrong? Well, let's go back to your calculations and make sure you made everything right. And there's a lot of times we go through and it's like, oh, wait, no, see, this is the wrong dilution. And you're ending up with something 10 times more concentrated or 5 times less concentrated than what you need. So definitely improve those solution prep calculations. So once you've done that, because we don't know what you're going to ask for, you have to tell us what you want. And you'll do that using a glassware request form. Now, the lab manual lists equipment and chemicals specific for that experiment that will be provided to you. You don't have to ask for them. So if it's in that list, you don't have to put it on your glassware request form. You do have to ask for anything else. And that's going to include beakers, volumetric flasks, volumetric pipettes, pipette bulbs, Sharpie markers, all those things that you may not necessarily be thinking about. You will have to ask for those. But just for the record, you do not need a glassware form for FTIR. Everything is in that kit for you already. The forms are available on Canvas, and you only need to submit one form per group. I only want one form for each group. So you guys are going to have to get together and work out your wet lab strategy and work out your glassware request form ahead of time. Okay? You cannot put this off till the last minute. There's a list of standard items available in Appendix 1 of your lab manual. So when it comes to the point where you say, gosh, I need 17 mils of this, can I get a 17 mil volumetric flask? Check Appendix 1. It's also on the back of your glassware request form. So it's on Canvas as well. And you look and you say, oh, they don't have 17 mil volumetric flasks. I guess I have to ask for a 25 and then figure out what you need to make that 25 mils. The forms are due by 5 p.m. the day before your lab. So it doesn't matter what time of day it is. Tuesday people, their forms are due Monday at 5, Wednesday are due Tuesday at 5, Thursday are due Wednesday at 5. Now, I am happy to look over them ahead of time. I would really encourage you to submit them ahead of time, especially the first one that you do. If you do that by 2, I will make a point to look at them before 5. And if there's a major glaring issue, I will send you an email. And at a minimum, it will say, there's a problem with your form. You may need to rethink it. I will try to give you some suggestions without directly telling you what's wrong with it, because we in education are compelled to do that. We cannot give straight answers. It's just a thing. You've probably figured that out by now. But if you can get them to me by 2, I guarantee you I'll look at them. I will try to look at them regardless, but I don't make any promises after 5 p.m. Now, we know you've never done something like this before. So we've given you an example of how to do all of these things. So in Appendix 2, there's a sample procedure for an NMR experiment that we actually used to do in lab. And interestingly enough, this experiment was built from an independent project. So, that's kind of cool, side note. But there's a sample procedure for an experiment called quantification of oxygenates in gasoline. And it was an NMR experiment. And there's a wet lab strategy associated with that. And the wet lab strategy is really just a list of solutions that need to be made. And in this example, it includes the glassware and equipment you need to make them. So that's an easy way for you to track what you need to put on your glassware request form. And you'll see for this experiment, there were a lot of solutions that needed to be made. But now we get to the glassware request form, and everything on this list in the glassware request form came from that wet lab strategy in the previous slides. So it's kind of a back and forth process. As you're building these, you'll sit down, and in the process of doing one, you'll be working on the other one as well. So hopefully it's not quite as labor intensive as it sounds, but it is going to be kind of a paradigm shift for you guys. And this is all building up to working on your independent project, because you're not going to go to the literature and have them give you a step-by-step list of all the things they made and how they made them and what equipment and glassware they used to do it. They're going to say, we use these solutions, and you're going to have to figure out what you need and how you're going to make it. So we're trying to get you in the mindset for approaching your independent project. So a lot of things that happen with these glassware request forms, some common issues that we have. Volumetric standards have to be prepared with volumetric flasks. You cannot assume that volumes are additive. And, specifically, 10 mils of ethanol and 10 mils of water will not make 20 mils of solution. If you've never seen someone actually do that in person, let me know, because it's kind of mind-blowing when you first see it until you think about what's happening. Excuse me. Make sure you ask for enough glassware to make all of your solutions. You don't want to try to wash things in the middle and reuse them, but don't ask for a whole bunch of extra things. If you get partway through your experiment and discover you need a couple more volumetric flasks, you can come to the stockroom and get them. The only time it will be an issue is for Flame AA, because that stuff has to be acid washed. But I will try to make sure that for that particular one especially, you have access to all the things that you're going to need. But it's really important. Don't say, well, I'm going to get 2 or 3 extras just in case. I have enough for everybody to do their stuff and enough for a few things to go sideways. But when everybody starts asking for a whole bunch of extra equipment, it really depletes my stock of glassware, and it gets really hard for people to do their experiment. Do take the time to look in the manual and see what's already provided, and don't ask for those things again. It gets confusing for everybody. So take that little bit of time, read through what's in the manual, see what we provide for you, and do go ahead and make sure not to include those. And this happens quite a bit. People think they've read the entire experiment, but they haven't. And there'll be entire sections of it that they've missed. And it's really easy to tell with the glassware forms because you haven't asked for enough things. So again, ask for everything you need. Don't expect to wash stuff in the middle. Wash it all at the end. And those are the two big things. That, and make sure and read the whole experiment so you're making sure and do all of the steps you need to do to complete your experiment. So Appendix 4 is just there to help you guys out. One semester we sent out a survey at the end of the semester, and one of the questions was, what should we have told you on the first day that we didn't tell you and you needed to know, and it would have helped make things so much easier? And I'm not going to go through and read all of these. It's in Appendix 4. You can pause the video. It's all here. But you'll see there's a couple of pages of that. But if you go back through and read carefully what all of those different things say, it says a lot of the same things over and over. So the big take-home messages from that are prepare before coming into lab and don't wait until the last minute. This course is a lesson in the problem with procrastination, okay? If you put things off until the last minute, you will not do well in this course, all right? It's not going to take a ton of work on the front end, but it is going to take just a little bit of effort before you come to lab, and a day or two before you come to lab. You're going to have to read the procedure. You're going to have to get with your lab mates, and you're going to have to work these things out. But when you do, you come into lab, you're prepared, it will go so much smoother, okay? So take those few minutes. Don't wait till the last minute. Prepare before you come into lab. Now, if you guys have any questions about any of this, please don't hesitate to ask. You can send me an email. It is better if you email me directly instead of trying to go through Canvas. My email is in the lab manual. I should have put it on a slide and I didn't. I apologize. But absolutely feel free to send me an email. Be aware that I leave campus between 5:30 and 6, and I get here between 7:30 and 8. So I'm not checking my email at 3 o'clock in the morning. So an email can be touch and go if it's late. You are welcome to come by the stockroom and ask me a question. If I'm in the middle of something, I may ask you to wait for just a few minutes until I get that wrapped up and I have a minute, but I will be happy to sit down and talk with anyone about any aspect of lab or their project. We talk about life sometimes, but if you have a question, don't hesitate to reach out, because if we don't know there's a problem, we can't fix the problem, okay? So that's it for this, and let's shut this down and we'll go from there.
Here's the round robin chart for this semester, and you will know your group assignments once you choose which group you want to be together with. And when you know your group, if you're in group A, next week in round robin week 1, you'll be doing the FAS experiment and FTIR, UVVIS, and fluorometry. So that's similar for each group, and you can follow this chart. And to make it easier for you to track which report is due when, I created this second chart right here. For example, if you're in group A, you will perform the FAS experiment on week 1, and then that report will be due on this week of February 11 to 17. That way you can keep track of each experiment and when it's due. So the pre-lab work. Angie told all about wet lab strategies and glassware forms. So I want you to know, remember in 456 we did the flowchart and an online pre-lab quiz. Not anymore, all those are replaced by the wet lab strategy and the glassware form. So these are the only 2 things that you need to do before you come to the class, and all these are set as group assignments on Canvas. So I would encourage you to work as a group and pick one wet lab strategy and the corresponding glassware form and submit it on Canvas. You only have to submit 1 copy, that way it will be populated all among the group members. And make sure you work as a group, which is very, very important to avoid conflicts and save time when you're in the lab. And when you are in the lab, we will do a quick spot quiz regarding each experiment. We will do it in person. We'll have multiple choice questions, probably 5 questions for each lab, and we'll have everything printed. So you'll take that quiz quickly before we start the experiments. And this is the example Angie was talking about, and you can find it in the lab manual under appendix and example glassware form. Okay, now let's take a pause before we transit to the next part of the talk, which is the special projects. So it's really, really important to think and reflect on what your visions are in life, and also what your career goals and where you want to be in 10 years, that kind of thing. Because you will be investing a lot of time and energy to do this project, your independent work, and it's a very unique experience. You'll have something on your own that you create when you get out of UT after this class. And you can talk about it, and it could be very relatable to your vision or your career goal. So take a step back and rethink what you want to do and how that can be something connected to your interest. So this class is an ongoing effort. We will like to hear from you. We like to know what you like to get out of this class, and also how we can help you get what you need during the class. So these are ongoing questions, and I put it out there so that you can share what you think, and your feedback is really, really valuable to us. Okay. Coming up with the idea could be overwhelming sometimes. Maybe you already know what you want to do, you already have a plan, and you have an interest that you thought of that could be an analytical chemistry question. That's okay. But also, for some of you, it might be really, really overwhelming to think about what my project could be. So I want you to pay attention to what's around you. Most of the time, there are little news popping up every day. That could be a question for an analytical chemist. For example, recently, probably a year ago, this FDA bans for red 3 came along, and that could be one interesting idea to investigate. And there could be some controversial things like this company proposing, or actually, they did some tests on over the counter medication and found out there are some carcinogenic compounds in them. Those kind of controversial topics that come to the surface might be a good alley to explore as your project. Or it could be something interesting to you. What are your hobbies? Do you like cooking? Do you like makeup and skincare? What make it interesting to you? Think about it and then see whether you can translate those type of question to an analytical chemistry question. And then there you go. There you might find a project there. And we need to start with the instrument assignments. So that's what we're going to do first. Right after this session, meaning after watching this video, wait for an email from Angie with the Google form link to submit your instrument request. Once you have a quick idea, think of which type of instruments that might work better with such an idea. The first thing to do is a literature review. It doesn't have to go deep, but in the surface level, you can do a Google search first, asking which instrument might work for this type of project. And then from there, try to find some peer-reviewed articles and get some ideas which might be the best instrument. And that way, you can submit that instrument request form telling us what's your first choice of instrument. And not only the first choice, we need 3 more choices from you so we can do the assignments carefully. Okay. So once we have those forms submitted, we'll do the instruments assignments and let you know which instrument you get. And then once you have that instrument, you know your instrument now, you can do 2 pre-proposals on those instruments. Why we need two pre-proposals? Sometimes your ideas might have some problems with it. So we may have to say no. And if you don't have a backup idea, it's hard. It's hard. You have to go back to step one and start over, which takes time. And we need to be proactive about this. So you will be doing two pre-proposals on that same instrument that could work. If one doesn't work, there might be a backup plan. So, for example, look at this. One proposed these two ideas, mercury in cosmetics and mercury in fish. So, what's the problem here? The problem is you analyze. We can't do mercury analysis in lab due to safety concerns. Because of that, if someone submits something similar like this, both ideas will fail as it comes. So we might need to go back and start over. Instead, try to keep those two ideas slightly different and think of two different topics or analytes, which might give you a better chance of making one of those work for the rest of your project. So, for example, alternative idea would be arsenic in rice. So, if you have proposed idea one to be mercury in cosmetics and idea two to be arsenic in rice, even the first idea doesn't work, we can fall back on the second idea, which is arsenic in rice. So this is the overview, how we're going to do this for the special projects. Just like I mentioned, the next thing to look out for is an email from Angie with a link to fill out your instrument request. Once we have it, we will do the assignments and you'll have your instrument. Wait for that instrument choice to work on the rest of the things. Once you know your instrument, you'll do more research on the peer-reviewed articles and find two good articles on two different ideas and do two pre-proposals. We'll go over two pre-proposals and tell you which pre-proposal might be the best choice. And once you have it, that's going to be your project and you'll write a full proposal and we'll do an oral defense, meaning you will tell us what you're going to do and how you're going to do it, and we'll give you some feedback. And at that point, we are ready to order your chemicals. We'll have everything ready for the last 6 weeks of the class so you can do your experiment when you come to the lab. So this last 6 weeks is very, very independent, meaning you are coming to the lab with knowing what you want to do and you tell us what you want to do. And that's why we do those wet lab strategies for you round robins. Because when it comes to the special project, you're the one who knows what's happening in each week. And you need to come up with that plan and or the strategy to know what to perform in the lab. So we are doing this practice run with the round robin experiments as the wet lab strategies. So you'll be trained to do this when it comes to your independent project. And same with the glassware form. Once you know your strategy, you'll fill out the glassware form and give it to Angie, and Angie will have your kit ready. And that's the only way we could know what you need for that week. So that's a whole practice run with the round robins using wet lab strategies and the glassware request form that goes in, which will help you build that skill. So last 6 weeks, you're doing your own experiment, and then we'll wrap up the semester with final presentation and a report. Okay. Something to remember that you will get the instrument request email soon after this, meaning you have 48 hours to complete your instrument choices. Once instrument choices are there, we will let you know which instrument you got, and then you can work on your pre-proposals. So coming up with the idea, we talk about this a little bit before. Think about your career choices, think about your interest, and think what you really want to do, and use your imagination and plan something interesting that you can talk about when you get out there and tell about your final experience at UT. Okay, some ideas might not work. Why? Because we have certain parameters for this course and some instrument doesn't really do what we expect them to do. So the course parameters, so this is a final project for analytical chemistry. And when it comes to analytical chemistry, we can ask two types of question. We can ask what's in it when you see a sample, and also we can ask how much is in this sample. So if you're just asking the question of what's in it, that's not enough for this project. We need a quantitative aspect to your project. So you can't just say what's in it, but also you need to go one step further and find a way to quantify a chemical in your project. Sometimes some things are already listed on the label. You can see it on the label, so why we have to design a whole new experiment to verify that? So if that's the case, think again. Think, is this a really valid question? If you're not trusting the label value, you need to give a really good argument why not, probably with some background research. Okay? Some experiments that we did for round robins already cover real world samples and this type of problems. So we might have done it already. So why you're planning a similar experiment? It will not give you something new to learn. Because of that, we will not allow people to do the same experiments as round robin experiments. For example, in 456, you did caffeine in coffee using GCMS experiment. So if you're proposing that same exact thing, that might not be ideal for this project. Instead, you can do, if you're still interested in doing caffeine in coffee or any other sample, you can use a different instrument like HPLC. That way, you'll have a new technique to learn. We can do that. Some things are affordable, some things are not. When it comes to this project, you are buying the sample and we buy everything else for you, but you need to bring your sample. Meaning, if you're doing lead in lipsticks, and if you want to do high end versus low end lipsticks, and you're going to check like 7 lipsticks of each, so much. You have to spend so much money to get your sample, which are lipstick samples, and paying that much money, can you afford it for a class project? Something to think about. Some things are not safe or not allowed to use in teaching labs, which I will touch on the next slide. Sometimes instruments are not capable enough. When it comes to quantitative experiments, you need to think of all the figures of merits that you learn in analytical chemistry. So, can my instrument go this low level of detection? Is it specific enough? Can I quantify my analyte in this huge matrix? Because we are dealing with real world samples, right? What type of interferences that could come your way? Things to think about. It's all matter when you choose an idea. And speaking of safety and what we can do and what not, there are certain standards that can be costly and we can't really buy them. Or some things are regulated, things like more scheduled substances or controlled substances. We can't do that. However, sometimes we can find alternatives to this. So if you have a doubt about it, just come check with us before you jump into conclusions. When you read through your sample prep protocols in a peer reviewed article, you might come across these particular chemicals, HF or perchloric acid or mercury, which are not allowed to use in our labs due to various reasons. And sometimes when you read the MSDS on the chemical that you want to use for your project, you might see these hazard codes with the one common word here, which is fatal, which is a very good sign that tells you we are not going to use that in our classroom. So very, very important to pay attention to these details when you're planning your project. We will go around and find we other alternatives together with you if you're really interested on a project. So come talk to us. The other thing to think about, can you legally obtain your samples? Some things are not legal to buy. Some things are not legal to use or get access to for a regular person. So things to think about, which is very, very important. Okay, these are the instruments we have in the lab. We have a very big array of instruments and which is listed right here. So if you go to Canvas and if you go to lab material page, in here, there's a tab called Getting Ready for Special Projects. And if you go in there, you have another link called Looking for an Instrument. So if you open this, you'll see we have a video for every single experiment, in every single instrument available. And that will be really good starting point before you fill out your instrument request, because this tells you what these instruments are capable of, what type of example projects we've done on these instruments. So I would highly recommend go through this page before you do your instrument request. So we do have certain other equipment available in the lab. So if you come across when you're reading through, you need a RotaWeb for your sample prep, we have it. So I just want to share what we have here. Even it's not shared here, sometimes we talk to people and we make it work. So we can find most of the time alternatives to what you're proposing. I want everyone to know that. So please ask and we'll go from there. So before we wrap up this intro, I want to kind of touch on something very important. You're going to put a lot of energy and effort into this project. In science, a lot of people work so hard in the lab, but that work will not get appreciated as much if you don't communicate it well to the general public. So the communication is big skill to develop as a scientist. And when it comes to communicating stuff, presenting stuff, the slides can do a whole much than you think. So just imagine you seeing a slide like this. Take a step, take a pause, and think about how you feel if you see a slide like this or like this. There's so many issues with these slides. I know these are kind of two extreme examples, but I want you to use this opportunity during this class where you will do two presentations, oral defense and the final presentation. Use that as an opportunity to practice this skill. Pay attention to your slides, how to present my work more meaningful way, how to build a story, that kind of thing is super, super important skill to build up. And this is a very safe space for you to do that. There are certain things that might work very well if you. I want to share some tips to be successful in this class: the communication, preparation, and we have your TA, me, Angie, we all are here to help. Getting things started early will help. I know it's your final semester, maybe a lot going on, but planning ahead will really, really help you get successful in this class. And I'm sure you have a lot of potential in you, and this is the place to thrive. I have this little assignment or little form to fill out if you are willing to. That will tell you more about you. If you like to share, go ahead and fill that on Canvas. And before we wrap up, a final note. You'll probably have seen this code many, many times before, but it resonates very much with this class and how we run this class. It's all about taking risk and how to learn to fail and pick up and come back and build a story and talk about what you learn through that experience rather than the final clear outcome. Okay, so I want you all to know that and use this space to try new things and play around and get the most out of this experience. Thank you.